بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. At the beginning, I would like to thank all of my students in microbiology course and immunology course. Hopefully, you will get the most benefit of this lecture today, inshallah. As you know, we have today to start with the gram-negative bacillus or gram-negative rods, the second part of gram-negative bacteria. As we know, the gram-negative can be classified according to their shapes into gram-negative cocci and gram-negative bacilli. We already talked and discussed about cocci, and today we will discuss a specific part of gram-negative bacillus. We know also that from the last lecture, bacillus can be classified into enterics and non-enterics. Enterics, those bacteria usually inhabitant in GI, enteric tract, and also we have mentioned about a week ago. We classified enterobacteria, as we know, into lactose positive and lactose negative according to their ability to ferment lactose. Today we are going to discuss non-enteric bacteria that can be classified roughly into typical gram-negative non-enteric bacteria, spirochetes, and atypical gram-negative bacteria. Typical bacteria can be classified or can be grouped into Pseudomonas, Brucella, Bordetella, Francisella, Yersinia. And you can notice that Yersinia have discussed before in enterics, so we consider it as enteric bacteria in case of enteric infection, or we can also consider it as non-enteric in case of some non-enteric infections. Spirochetes involve Treponema, Leptospira, Borrelia. Atypical bacteria, those bacteria that lacking some features and some general features that characterizing typical bacteria or general features of bacteria like cell wall. The most important feature that lack in atypical bacteria, cell wall. Those bacteria or those groups involve Rickettsia, Chlamydia, and Mycoplasma. Let's get started in the typical bacteria. And most of typical bacteria, as you know, most of typical gram-negative bacteria are aerobics. So we can also characterize gram-negative rods or gram-negative bacillus according to their requirement to oxygen into aerobics, facultative anaerobes, and obligatory anaerobes, according to their requirement to oxygen. This is another way or other aspect of classification. We can classify them into aerobics, facultative anaerobes, and obligatory anaerobes. Obligatory anaerobes include bacteroids. Facultative anaerobes include most of enterics, those non-lactose or lactose negative and lactose positive, and those bacteria that also non-enterics like oxidase positive, for example, Haemophilus and Pasteurella. Those bacteria are non-enterics because they are non-included in the general criteria of enterics, like oxidase. Those oxidase negative are only enterics. Oxidase negative, either lactose positive or lactose negative. And also we have aerobics, gram-negative bacteria like Bordetella, Brucella, Francisella, Pseudomonas. So the non-enteric bacteria are those bacteria that involve or that pertain some criteria, some general criteria, some general characters or features. For example, Lipopolysaccharides, as usual in all gram-negative, we know that all gram-negative involve or return in their cell walls a specific structure called lipopolysaccharides. It's a two-part, lipids and polysaccharides. Usually this part or this component is highly immunogenic because it's recognized, strongly recognized by immune system, and the immune response usually harmful and usually lead to some changes, some physiological changes. So we consider usually lipopolysaccharides, we consider them as virulence factors because of this, of their effect or their harming effect. Also, most of non-enterics can grow in presence of oxygen. So usually these infections are, or these organisms are aerobics. So usually the aerobic organisms can lead, or the virulent aerobic organisms can lead to some respiratory infections. The non-enteric also can be classified or subclassified into respiratory infections or respiratory infectious organisms like Haemophilus, Bordetella, and Legionella, or those organisms can lead to opportunistic infections like Pseudomonas, or those organisms that lead to some zoonotic diseases like Francisella, Brucella, Pasteurella. And zoonotic infections means those infections that transferred from animals to humans. We know that also Yersinia pestis, considered as Enterobacteriaceae, but usually we include Yersinia pestis in this group as non-enteric because they involve, as we mentioned now, they are involved in some non-enteric infections. So, the first class, those organisms that lead to some respiratory tract infections. We have some examples like Haemophilus. Haemophilus as a genus, characterized by specific characters. For example, pleomorphic configuration. And we mentioned before the pleomorphic form or shapes, those shapes with unstable shapes or variable shapes, sometimes long or short rods or bacillus, and sometimes they are in form of palisade structure or palisade arrangement and so on. But usually they are generally a small cocci, as in case as we characterize it as cocobacillus, or long bacilli, or intermediate bacillus, so we call it pleomorphic. Usually Haemophilus involve capsule. Actually, some strains involve capsules, or able to synthesize involve capsules, or synthesize capsules, and some other strains are not or are unable to synthesize capsules. Some of these strains called type B, Haemophilus type B or HIV, which is the most virulent strain. Usually this strain is a specific pathogen specifically infects young children. So the target age of this bacteria is about from 1 to 5 years. Some other strains that are unencapsulated, some can cause or can lead to some serious diseases. For example, pneumonia, especially in elderly patients, and chronic lung diseases. usually Haemophilus involved or transferred through respiratory droplets. So the main way for transmission is respiratory droplets. So we consider Haemophilus influenza infection as droplet transmitted disease, droplet transmitted infections. Usually H influenza or Haemophilus influenza normally inhabited in the upper respiratory tract. And also they can colonize or they can normally exist in conjunctiva and genital tract. So the humans are natural hosts for this type of organisms. The pathogenesis refers to some virulence factors. We mention usually virulence factors for specific types of bacteria or specific type of microorganisms. Those infections or those factors responsible for the infections. Without these factors, the organism would not considered as infectious or as a pathogen. So the pathogenic factor or virulence factor are very important to know when we are studying microorganisms or studying microbiology. One of these unique actually virulence factors, immunoglobulin A protease. All of us know the immunoglobulin A, which is a secretory immunoglobulin which exists in abundance in our fluids or in body fluids, like for example saliva, breast milk, sweat, and so on. So those immunoglobulins are responsible for defense in all of these interests, portal of interest, like respiratory tract. They exist in abundance in respiratory tract solutions or secretions, and also in genital tract secretions, in GI secretions. So we can consider them as guards at the portal of interest for our bodies. So the immunoglobulin A protease enzyme that produced by Haemophilus influenza is the virulence factor that destroy immunoglobulin A. So the end result, the immunoglobulin A will be finished and will be dysfunctional. So the organism can colonize easily and can lead to some infections at the sides and upper respiratory tract mucosa. Also H influenza, among their pathogens, their virulence, they can enter the bloodstream and disseminate to different sites, to different organs, and lead to specific and other infections like meningitis, for example, and other related infections. So H influenza can be involved in different types of infections. For example, respiratory tract infections and the other infections that disseminated from respiratory tract as a portal of entry, so they can lead to some otitis media, sinusitis, epiglottitis, and pneumonia. All of these infections are connected with each other. They can start from colonization of respiratory tract, and we know that the respiratory tract are connected with the middle ear and to sinuses and the pharyngeal cavity and lungs. Other types of infections also that related to ability to invade bloodstream that can lead to some serious infections like meningitis due to they carried out in the bloodstream and can reach to meninges and lead to very serious conditions called meningitis, and also they can lead to bacteremia, existence of bacteria in blood, and septic arthritis and cellulitis. Still, they can reach to any site. They can reach to any place, distant place, so can lead to some serious infections or systemic infections. How to identify Haemophilus influenza? We can identify it if we are suspecting a meningitis. We can identify it in ground staining of cerebrospinal fluids. We can take a sample from cerebrospinal fluids to looking for bacteria, the gram-negative bacillus, in the CSF on the cerebrospinal fluids. Also, we can culture it. We can culture bacteria in a specific media called chocolate agar. We know that H. influenza is fastidious organism. We know that. What's the meaning of fastidious organism? Those bacteria requires high amount or specific components of nutrients, or high amount of nutrients. So chocolate agar, one of the enriched media that can be used for growing of some fastidious organism like H. influenza. And H. influenza needs a specific requirement, nutritional requirement, like factor X and factor V, or factor 5 and factor 10, which is hemin and NAD-H or NAD4 respectively. Also, among identification, we can identify Haemophilus influenza by identifying the type B capsule, which is polysaccharide capsule. It can be identified serologically or immunoserological methods by extracting them from CSF or from cerebrospinal fluids, by doing capsular swelling reaction, specific tests that can be used for detection of capsules, or by means of immunofluorescent staining or immunofluorescence reactions. How to treat the infection? By specific antibiotics. The ideal treatment should be following the antibiotic susceptibility testing, by doing antibiotic susceptibility testing, but empirically we can treat the infection by ceftriaxone. But at the same time, the sensitivity testing is very important. Also, we can treat by trimethylprim sulfamethoxazole, what's called co-trimoxazole, or ampicillin plus sulbactam. Both are synergizing each other to treat sinusitis, otitis media, and urinary tract and upper respiratory tract infections. The prevention, we can predict them, the prevention procedures. How to prevent this disease? You can prevent this disease by using of HIB, Haemophilus influenza type B vaccines. And also can prophylact or can protect individuals or surroundings, family surroundings, especially childs that surrounds patients, by using of rifampicin antibiotic. Some other Haemophilus species other than Haemophilus influenza called Haemophilus ducreyi. Haemophilus ducreyi actually is sexually transmitted disease. It's not respiratory tract infection or respiratory infecting organism. They infect genitalia and transmit sexually and lead to specific lesions called soft chancre or chancroid. Those infections can be treated by azithromycin. Second example of aerobic bacteria or aerobic gram-negative bacillus called Bordetella. And Bordetella involve different species. The most important species that we have, Bordetella pertussis or B. pertussis, one of the most common human pathogens of this genus. Actually, pertussis are connected with very common infections called whooping cough, السعال الديكي, and other infections like parapertussis, Bordetella parapertussis, B. pertussis and B. parapertussis. It's similar to whooping cough also, but they are slightly different than pertussis. Bordetella is aerobic, as we mentioned now. Bordetella also encapsulated Cucobacillus, very short. It looks like cocci, so we call it Cucobacillus. And we can serotype them according to their surface molecules. They have surface molecules or surface polysaccharides can be characterized, can be used for characterization of this bacteria. The main mode of transmission of Bordetella is through droplets, so they are also considered as droplets transmitted infections. So the main way for infection or transmission through contact, direct contact, through coughing or sneezing or talking or even kissing of the patient. Actually, this disease has very high